All right. Hopefully you were all able to calculate the pH from the H plus or OH minus. And today we're going to go the other way. We're going to calculate H plus and OH minus from pH. So if the calculation that we used to go from H plus to pH yesterday was this one, pH is equal to negative log of the concentration of H plus. The opposite version is going to look like this. H plus is equal to something called the anti-log of negative pH. So if you know the pH, all you have to do is make it negative and take the anti-log. So you're going to ask me, well, where is this anti-log button that you're talking about, Mr. O? Well, you know where the log button is, right? To get to the anti-log, let's zoom in a bit. This right here, 10 to the x, that's the anti-log. How do you get to it? Well, it's blue, and it's over the top of the log button. That means we're going to use our second key, just like we did to get to the EE function on our comma key. So if you're trying to get to the anti-log function, all you have to do to get to this is hit second and log, and then just enter the negative pH, and you're golden. So let me show you how this works. Take an example here. Okay, so let's say I was going to ask you to tell me the concentration of H plus in a solution with a pH of 2.4. So we're going to plug this right into this fresh new equation. H plus, or the concentration of H plus, equals anti-log of negative pH. In this case, the pH is 2.4. So let's bust out our calculator. Hopefully you brought one. I got my fancy one. And so what we're going to say is, let me make this smaller so I know it's on the screen. Smaller, please. Okay, so put this over here, and we'll turn this on. Okay, so anti-log is the shift function of the log button. I'm going to hit second, log, negative, I'm not using the minus sign, I'm using the negative sign, 2.4. What this tells us is that our concentration of H plus in this solution is 0.00398. You can leave it like that, and that's totally fine. If you wanted to put it into scientific notation, you guys know how this works. You need to move the decimal 3 places to the right to get it into a blank point blank format. And so we're going to say 3.98 times 10 to the negative, because we moved it 3 places, negative 3. So our concentration of H plus is 3.98 times 10 to the negative third. Okay, let's try a couple more here. All right, this question actually has 3 parts. It's asking for the concentration of H plus, it's asking for the concentration of OH minus, and it says that if the solution that produced this H plus is H2CO3, what's the concentration of the H2CO3 that produced this? So let's do all 3 of these. First off, what's the H plus? We know that H plus is equal to anti-log of negative pH. In this case, our pH is 5.3. So we're going to plug it right into our equation, and we're going to say, all right, antilog is shift log negative 5.3. This tells us that our concentration of H plus in this solution is 5.01 times 10 to the negative 6. So there you go. 5.01 times 10 to the negative 6. What's the OH minus in this solution? Well, you guys know how to find OH minus because you know that OH minus is equal to KW over H plus. You know that KW is a constant, 1 times 10 to the negative 14th. And you know that all you have to do is plug in your H plus, which you just found, 5.01 times 10 to the negative 6th. So let's throw it in there and see what happens. We're going to say 1, clear this first. We'll say 1 times 10 to the negative 14th. We're going to divide this by 5.01 times 10 to the negative 6th. This is our concentration of OH minus, 1.996 times 10 to the negative 9. You could feel free to round that if you wanted, or you could leave it just like it is. Now this third question is probably the one that's going to give us the roughest time, because it's asking us what's the concentration of the H2CO3 that produced this H plus. And believe it or not, this is a problem that you already know how to do. We know how to write dissociation equations for these. We know that H2CO3 is an acid with 2 H pluses in it. That's what the subscript tells us. So when it dissociates, we get 2 H plus in solution and a CO3 2 minus that we don't care about. And so we've been doing this previously where if we knew the concentration of this, we would simply multiply it by whatever coefficient we had to get to this. Well, in this case, we don't quite know that. In fact, we're going the other way. What we're going to do is we're going to take the H plus that we got from the first part of this problem, this guy right here, and we're going to say, okay, we know the H plus already, 5.01 times 10 to the negative 6th. The question is, if we already know the H plus, if we already know this guy, what did this have to be to produce this? Which means that we're not multiplying by this coefficient. We're going this way. We're trying to find this, which means we're not going to multiply by a coefficient. We're going to divide. If we take 5.01 times 10 to the negative 6th and divide it by 2, what do we get? What's the H2CO3 concentration that provided this? So we're simply going to take this and divide it by 2. We get 2.505, just call it 2.5, times 10 to the negative 6th. That's this. Okay? So that's all you have to do, ladies and gentlemen. Take it for a spin, please, and I will see you all on the next one.